So Eric, this is primarily for you, but there may be other people who would want to know about checking out TIFKAM. What we have here is a standard IC with a sequencer in it, and it is running the observing program, same old observing program that you run at the observatory. And the command that we're executing is TV, and that reads out the detector over and over again. As you remember, with an IR detector, a readout is actually two readouts. It's a pre-read, and then you do your exposure time, and then you read out again. And what you get is the difference between those two. And that's what this is doing now. You'll see it sits here not doing anything because it's doing the pre-reads. And now as it's displaying a new image, it's doing the post-reads. One other trick, of course, is that instead of just being the difference, a constant is added to the data after you take the difference between the pre-reads and the post-reads. That constant in this particular configuration is 900, so I'm actually displaying between 880 and 940 to get a nice display that shows noise as it goes through the read. Dan and I have already checked out this HE as much as we can by probing here on the 37 pin connector. I have a cable that's got the correct 37 pin, the correct, what are these called, Dan? Coaxicon females. So I can just poke it into each one of those, and then I've got a bare ends on the other end. So we've done that, and we've convinced ourselves that it is all correct, what is coming out of the 37 pin. So what we'd like you to do is to go ahead and connect the instrument up again. So connect up the instrument again. So you want to put the black cable on here, connect it to TIFKAM, get it cold, and hopefully it will not be working then. It'll still be bad when you get that configuration. And then we're going to show you where to probe on the clock bias board to confirm that those signals are correct still, even when the instrument is connected. There could be a short somewhere, there could be some other odd thing going on, and so we're just going to go through and check them again. We have made a spreadsheet for you, which is hopefully a fairly good presentation of the things you want to check. And there are two types of things that you're going to be checking. The first is clocks, and all of those will be on pins here on the clock bias board. You notice there are a ton of clocks available, and we only use a few with the TIFKAM. And you'll be probing each of those on these stand-up resistors here. That's the easy way to probe those. You could go directly to the pins on the IC as well if you wanted to. The other thing we'll be checking are DC voltages, and those you're going to pick up on pins of the 96C on this bed of nails here with 96C pins. And what I would recommend is that you make up yourself something like this to get to those pins, which is just a female pin of about the right size and a little piece of shrink tubing on it and a wire coming out the back. So that's an easy way to just put it right over top of one of these pins.
I'll put one in the box.
Like that? Dan's going to send you one. Maybe Dan will even send you two. So let's just do it here. Let's just do it here and start. We'll do the DC voltages first, I guess. And so the first one on here is Mux sub, and that is the 96C on pin B7. So I'll just count over here 7 times. 1, 2, 3, 4, 5, 6, 7. It's yellow wire. And voila, $0, 0 cents, 0 volts, exactly what it's supposed to be. And in fact, on that one, that really is ground. And so if you really wanted to go over and check on ohms, and it is 0 ohms too. So it's not necessary, but it's a nice thing to do. Then the next one is pin 9 on the, pin 9, B9. So I can just jump over 2 here. 1, 2. It's a red wire on that. And it's supposed to be 5 volts, and it is 5 to the precision required. The next one is pin 10. This is nicely sorted here. I don't have to count over and over again. And that's supposed to be 3.4 volts, and indeed it is. 11 is the next one. 1/4 volt, just like it's supposed to be. 12 is the next one. Boy, this is easier since we've sorted it, I'll tell you. 3/4 of a volt. Notice that's 0.75, which is supposed to be. Bias power is the next one, which is 16. So I got to go 12, 13, 14, 15, 16. 5 volts, that's good. Then there's a clock, and then we go to 18. This is 16. 17, 18 is supposed to be $0, $0.00. And 19 is the next one, also 0. And again, we get 0. 21, so we go 20, 21. 0.75, that's what it's supposed to be. The next one is an output. And the outputs are all covered up with shrink tubing. So if there is some good reason for reading that voltage, you can. You do want to be careful not to short it to, in fact, in the case of the TIFKAM detector, I think you want to be careful not to short it to 5 volts. I think shorting it to ground is okay, but don't do it anyway. So you could stick a probe in the top of the where the shrink tubing is to measure those output node voltages. I have no idea what they should be with the detector on there. I would guess a couple of volts, but I don't really know. If you were to measure those voltages, you would find that they are all 5 volts. They're pulled up by 10K resistors on the post amplifier. I won't say any more. So what did we just do? We just did...
We get to the first output.
23, so 23 is 2 pins down from there. 23 is supposed to be 0. We got 0. 24 is supposed to be 5. We got 5. 25 is an R load, so we're ignoring that. 26 is 0 again. 26, 0, that's good. And 28 is a load. 29 is 0. 26, 27, 28, 29, 0. And next one is 32. That's the very last thing here. That's also 0. That's good. And then we have to jump over to C2. C is this row of pins here right next to the connector itself. There's C2. If you have any questions about what's what, you can always look over here. Here's a bed of nails without any pins, and you can see there's C1 right there and C32 there, and B is the middle row, and A is the all ground on this application. Should have told you that to start with. We're now on C2, which is supposed to be, oh, that's a clock, so we don't want that just yet. C4 is 3.4 volts. Sorry, no, C4 is 1/4 volt. There it is. C4 is a 1/4 volt. And C30, down here, 32, 31, 30. That's the one that's 3.4 volts, and C32 is supposed to be 5 volts. Ta-da! So we've checked all of the DC voltages now, and everything was fine. Well, we knew that. And then we can go and do the clocks. I probably should have pointed out that this is a good place to get your grounds. This is, you know, the extra ground that goes down to the ADC that helps with some kinds of noise, and this is ground too, so you can clip your probe on there, and you can clip your scope probe on there when you're ready to do that. Now we can go through the clocks, and the first one is U4 pins 1 and 2. That's not right. We got to fix that, Dan.
Okay.
It's clock switch 12. Switch 12 should be 2 and 15. U4 2 and 15. That's okay. That's just the 5 is missing off there. So if we can find U4, the U numbers are a little hard to find. Go back pointing with my pencil, I guess. Here's U12, the number's right there. U11, I don't know if there's a U number for this one or if it's buried somewhere, but it's U10. This is U9, and the other one you need is U4 over here. So in fact, you know what I can do? 4, 12, 11, 10. I don't think we need 9, but that's 9. Don't be moving the chips around, you'll be confused. All right, so the first clock we want to look at is called clock 2. And clever name. U12 pins 2, so 12 is here. This is the 215N, so I can clip right on that resistor there. And if you look at the yellow trace, we have a clock on the scope. Sorry, seconds per division. There we are. And I'm going to get rid of 2, I think, here. How do I get rid of 2? We're off. Just thought it was more confusing than necessary to have 2 on there, but you know how to turn off the trace? I don't know how to turn off.
You can't just press the blue button again?
There we go. Okay. So I'm on this signal, and you'll see it's a positive going pulse. And that, I would have thought that was at the pixel rate. I don't see that at the pixel rate. Thinking. Hold on just a second here. Okay, let's just make sure we got clocks everywhere we're supposed to. That was switch 12, which is clock 2_3. Clock 2, 1, 2. Oh yeah, that's quadrant 3 and 4 and quadrant 1 and 2. Let's go to the next one, which is U10, 7 and 10. That's this end of the chip, so it's that little resistor there, and there is a clock again. That's L-sync. You get one of those on each line, and they come in pairs for some reason, but that's what the coding sheet shows, so that's correct. And switch 2, which is 11-2. That's this one here. And that is read. No, it's reset N. Oh yeah, that is reset N, which occurs just at the beginning of pre-reads. So it's not there a lot of the time, and then it is there for a little while, and then it's not there again. So don't be confused by that. And then F-sync, which is switch number 3, and is U11, 7, and 10. What's the other? This in. But those have gotten backwards, Dan?
Could be.
That's 7 and 10. That's not F-sync. Maybe it is.